Hello everyone, this is Roshan C L from Department of Studies in Computer Science, Manasa Gangotri, Mysore, presenting a detailed overview on TCP/IP. First, it's important to know about what is TCP/IP. TCP/IP or the Transmission Control Protocol or Internet Protocol is a suite of communication protocols used to interconnect network devices on the Internet. TCP/IP can also be used as a communications protocol in a private computer network, an intranet or an extranet. Moving on to some more details, TCP/IP specifies how data is exchanged over the internet by providing end-to-end communications that identify how it should be broken into packets, addressed, transmitted, routed, and received at the destination. TCP/IP requires little central management and it is designed to make networks reliable with the ability to recover automatically from the failure of any device on the network. The two main protocols in the Internet Protocol suite serve specific functions. TCP defines how applications can create channels of communication across a network. It also manages how a message is assembled into smaller packets before they are then transmitted over the internet and reassembled in the right order at the destination address. IP defines how to address and route each packet to make sure it reaches the right destination. Each gateway computer on the network checks this IP address to determine where to forward the message. A subnet mask is what tells the computer or other network device what portions of the IP address is used to represent the network and what part is used to represent host on the network. Now let us see how TCP/IP works. TCP/IP uses the client-server model of communication in which a user or machine is provided a service by another computer in the network. Collectively, the TCP/IP suite of protocols is classified as stateless, which means each client request is considered new because it is unrelated to previous request. Being stateless frees up network paths so that they can be used continuously. The transport layer itself, however, is stateful. It transmits a single message and its connection remains in place until all the packets in the message have been received and reassembled at the destination. The TCP/IP model differs slightly from the 7-layer Open Systems Interconnection (OSI) networking model designed after it. The OSI reference model defines how applications can communicate over a network. Moving further, let us know the prominent layers of TCP/IP. TCP/IP model layers. TCP/IP functionality is divided into 4 layers, each of which include specific protocols. The application layer provides applications with standardized data exchange. Its protocols includes the HTTP, FTP, Post Office Protocol 3 (POP3), Simple Mail Transfer Protocol (SMTP), and Simple Network Management Protocol (SNMP). At the application layer, the payload is the actual application data. The transport layer is responsible for maintaining end-to-end communications across the network. TCP handles communications between hosts and provides flow control, multiplexing, and reliability. The transfer protocols include TCP and User Datacom Protocol (UDP), which is sometimes used instead of TCP for special purposes. The network layer, also called the Internet layer, deals with packets and connects independent networks to transport the packets across the network boundaries. The network layer protocols are the IP and the Internet Control Message Protocol (ICMP), which is used for error reporting. The physical layer, also known as the network interface layer or data link layer, consists of protocols that operate only on a link, the network component that interconnect nodes or hosts in the network. The protocol in the lowest layer include Ethernet for local area networks, LANs, and Address Resolution Protocol ARP. After knowing about the layers, here is a schematic diagram of the layers that one by himself can understand the working of layers by looking at the simple diagram. Moving further, let us know the importance of TCP/IP. TCP/IP is non-pre non-proprietary and as a result is not controlled by any single company. Therefore, the Internet Protocol suite can be modified easily. It is compatible with all operating systems so it can communicate with any other system. The Internet Protocol suite is also compatible with all types of computer hardware and networks. TCP/IP is highly scalable and as a routable protocol can determine the most efficient path through the network. It is widely used in current internet architecture. After knowing some information about TCP/IP, it is very important to know about the history of TCP/IP. The history of TCP/IP. The Defense Advanced Research Projects Agency DARPA, the research brand of the US Department of Defense, created the TCP/IP model in the 1970s for use in ARPANET, a wide area network that preceded the Internet. TCP/IP was originally designed for the Unix operating system and it has been built into all the operating systems that came after it. The TCP/IP model and its related protocols are now maintained by Internet Engineering Task Force. Here are some most efficient uses of TCP/IP. TCP/IP can be used to provide remote login over the network for internet interactive file transfer, to deliver email, to deliver web pages over the network, and to remotely access a server's host file system. Most broadly, it is used to represent how information changes form as it travels over a network. From the concrete physical layer to the abstract application layer, it details the basic protocols or methods of communication at each layer as information pass through. At the end, I thank one and all for giving your valuable time on my presentation. Thank you.